Here is a speed time graph for a train journey between two stations, and the journey took 100 seconds. And in part A, we need to calculate the time taken by the train to travel half the distance between the two stations, showing all of our working. So the first thing we need to know is that on a speed time graph, the distance is the area beneath the graph. So how are we going to do that? So for the shape here, what we can do is if we split it at this line here and then this line here, we have got three different shapes that we know how to work the area out of. We can work out the area of a triangle, of this rectangle here, and this triangle here. So we're going to do that between this point and this point. So this is halfway between 20 and 40. So we've got 30 along here. For every two of the little squares here, we go up 1. So this would be 11 and this would be 12. So the area of a triangle is half multiplied by the width multiplied by the height. So for this one here, we're going to have a half multiplied by the width, which is 30, multiplied by the height, which worked out to be 12, giving us 180 meters. The distance represented by this part here is 180 meters. Now look at this over here. We're going to work out the area of a rectangle. So the width, we're going between 30 and 80, so that's 50. So 50 multiplied by the height, it's the same height as before, up here, so 12, giving us 600 meters. And last but not least, this triangle here. So the width, we're going between 80 and 100, that's going to be 20. You can remember to multiply by half as well because it's a triangle. And the height, we're going up to 12 still. That gives us 120. So in here, 120 meters. So to work out our total distance, we're going to add them all up. So we're going to have 180 plus 600 plus 120, giving us 900 meters. Now we need to calculate the time taken by the train to travel half the distance between the two stations. So half the distance will be 900 divided by 2, giving us 450 meters. So we need to work out how far along here do we need to go to have an area to the left of it, giving us 450 meters. If we think about this, 450 is more than 180. So we know we're past this line here. This line will be 780, because that's 600 plus 180. So we know it's less than that. So we know it's somewhere within this box here. Since we know we've gone past 180, if I just do 450 minus 180, that gives us 270 meters. We need to find where along here. Now just looking at the rectangle past 30 seconds, we get an area that's 270. We can do that with a little bit of algebra. So we don't know the width, so I'm just going to call that x. But we do know the height, that's 12, because we can see that that's 12 all the way along there. And it's going to equal 270. So if I divide both sides by 12, we're left with x on the left-hand side and 22.5 on the right-hand side. So if we have a look up here again, from 30, we need to go 22.5 along this way. So if we do 30 plus 22.5, that gives us 52.5. And that is seconds. So just explain that on the diagram, what we've done is if we go along to plot 52.5, that would be just past this point here, which means this area is 270 meters. So in total, going from 0 to 52.5, the distance which we've travelled is a combination of these, giving us 450 meters, which is what we wanted to find out. We want to find out how long that takes. Well, that takes, going down here, 52.5. So we know we got the answer, 52.5 seconds. So we get our first mark for starting to find the area under the graph. So look at the area of the individual shapes. We get our second mark for getting that to add up to 900. Then we get our third mark for going through this process to get the 22.5 value. Then we get the fourth and final mark to use that to find out that it's 52.5 seconds.